Hello. Oh, you're using bad microphone. Let me switch you over. JK, apparently that's the one it's going to use.
Hey,
Weird.
everyone.
Zoom is not noticing my fancy mic, so y'all are getting laptop mic today. We'll have to figure that out another time.
Horrible.
I know, right?
Yeah.
Just going to give everybody the full podcaster experience. Just make sure I can. Oh, Lordy, where are you being? Trying to figure out what to share, but I opened up the share screen and what I got was a bunch of cannot share exclamation points, which feels really icky. Let's see if this actually works. Oh, it's a system preferences thing on this machine. Tell it that it can do that.
Yes. The work on me next to him, I gotta get this.
I gotta bounce and come back to have screen sharing. I'll be right back.
Yeah. How is everybody?
Doing great.
Good.
How are you?
I'm good.
I'm good. Thank you for asking. Hope everybody's break was good. Felt like a long time, actually. Usually it feels very short, not long enough.
Yeah, somebody made you all fight a dragon, so that ate into some of it, I'm sure. It's good times.
The dragon
Right.
fighting was very exciting.
Good. If anybody did that and was not in the slightest bit ever confused or frustrated during the whole fire I just threw you into, then you probably don't need to be in here. And I'm guessing all of you were, because I even was at a couple of steps where I was like, wait, you want me to do what? And I know JavaScript. So I want to start just by saying whatever your experience was with that, good job putting in some work on it. And we'll actually make sense of it, hopefully, by the time these 4 weeks are over. And you'll be like, oh, that one was chump change. That's easy now by the time we're done. Right? So the expectation is certainly not that you understood all of that. I have talked with some of you independently already during this process leading up to today. And I think most of you seem to be doing a pretty good job of that. But one of the things I've mentioned is that learning a programming language like JavaScript requires iteration. So you're going to have to come back at it over and over and over again. So you're not going to understand everything there is to understand about functions the first time you write a function. You're going to have to write a bunch of functions, and you're going to write some functions that don't work, and you write some functions that do work, and then you'll start to make sense of all of that. And the same is true for variables and other data structures and all that sort of stuff. So the way we're going to kind of take this apart, I linked the curriculum updates I just did in the channel, and that is subject to minor changes as we go along, because I'll adjust to what you all need. But I'm just going to go ahead and share my screen here real quick, make sure this works right. Get us started, I think. Okay, you are all seeing my thing. Can I hide these controls? Please go away. Thank you. Okay, so, oh God, my Vim keys might do weird things to Zoom. We're about to find out. It's been a minute since I've used Vim and Zoom at the same time. Okay, so here we go. I'm going to stay a participant. All right, so I'm going to pull up the README for today and kind of use this for now as just something we can kind of follow along with. And we're going to do a little more talking today and a little less coding than I will be doing for all the rest of these classes. There's just a little bit of kind of trying to help you all sort of get your sea legs, so to speak, that we want to do here, right? And that's one of the reasons why I wanted to start you all off with that pre-work project is we are going to learn a bunch of new jargon for you. You're gonna learn keywords, you're gonna learn structure, and all of a sudden, as some of you already noted, commas and semicolons just became like way more important in your life than they probably were before this, right? Square brackets, all those sorts of things. So my primary goal for this entire module is to help you all feel comfortable reading JavaScript. And I kind of mentioned that when I threw you the dragon exercise. I think if you can really learn to read some JavaScript and make sense of it.
I'm watching that. I'm a mentor in this class.
Cool. All right. So what we're going to be doing here is trying to help you read JavaScript first and foremost, because I believe that if you can learn to read code like you would read other text, then writing it becomes easy. Because I think one of the things that it's easy when you're getting into programming languages that's an easy misconception to have is that being good at writing code is about writing code. And I think more often than not, being good at writing code is knowing which code to write and what code not to write, and also which problem you're trying to solve. And those things are harder to sort of suss out. But somebody once said to me, every line of code you write is a liability. And when you, if any of you, carry on and this is a profession, that's a reality. But it's true even when you're working on these little projects, when you're making your own choices on the coffee shop app, et cetera, as you add code, you are also adding something that could have a bug in it. You're adding something you have to maintain and make sense of. The most elegant solutions are often the ones that require the least code to write, and more importantly, are the most readable. So one of the other things that you will experience as you continue on in this life is coming back to your own code 6 months later, or a year later, or 2 years later, or inheriting a project somebody else built that you haven't seen before. And being able to find your way through it is a key skill, but it'll also enable you to learn on your own a lot better if you're able to look at examples of different JavaScript concepts or how things are done and really be able to sort of parse that code and make sense of it. So today I'm going to help you try to get some big picture bearings. I've stolen much of this from Zach's previous work, so I'm going to give him credit where that's due. But I want to point real hard at this heading. I made not a heading by putting a hyphen in front of it, which is today's a high level overview, and you're not going to understand half of what I say today. I'm going to try to make it less than half that you don't understand. But I do want you to realize that, like, even though we've now done a role-playing game exercise, or at least part of one, and now we're going into class, we are going to continue to kind of go back to the beginning over and over again and work our way through JavaScript as a concept, and really JavaScript as a lens for teaching you like core fundamental programming language concepts, which will make it easier for you to learn other languages if you want to. So that's kind of what we're going to dive into today, is getting you some bearings and setting you up with that. And I'll try my best to give you some live examples as we go. And if we have time left towards the end, I'll be happy to field any pressing questions about your role-playing game exercise that may still exist at that point. Part of your homework for the next class will be to finish that exercise, the dragon slaying, if you have not. So if you didn't, don't worry about it. We are also only going to really kind of help you get your bearings on maybe the first half to 2/3 of that in this class, and then we'll carry on with that in the next class. So one of the first things that I want to talk about here is order. And I had a lovely little chat with Zach about this right before we started. Order matters in all of the things that you've been doing so far, but in very different ways. And when we talk about order here, I'm really just talking about running down these line numbers, right? So I've got line 1, and now I've got, oh yeah, Zoom, you're doing weird things to me, stop it. Line 2, okay, so the order of these lines are comments. They don't really matter. You've written a bunch of HTML already so far. You've written some CSS so far. When we write an HTML document, here, I'll just go ahead and boilerplate one up so we have something to look at here real quick. Yay for boilerplate. Okay, so here is the beginning of an HTML document. This is also in order, okay? Starting with HTML, which is what you learned first, when we talk about the order of the tags or the elements here, what we're talking about is what we would call document order. So that is the order in which elements appear in the source code, in your HTML. What's important to know is that that doesn't necessarily mean that's the order they show up on the page when the page is rendered by the browser, because we can use CSS to change position of things. We can, with fancy front-end frameworks, do things like teleporting and all this sort of stuff. So we can have an element exist in one place in the document, but not necessarily render it in the same order on the page. We want to be careful about when we do that, just as a quick shout out about accessibility things. So I'm a big accessibility proponent. If you're ever curious about whether or not you've done a good job with basic accessibility practices, try to look at a page you built it with a screen reader and realize that that's what anybody who is visually impaired is probably using to navigate that. And you'll be either pleasantly surprised or horrified at how hard you made that site to navigate. So when we have things out of document order, compared to how they're visually arranged, that can be really hard for screen readers sometimes. So we just want to be, there's ways to work with that, but we just want to be careful about that. CSS kind of in some ways is similar to HTML in this sense. So the order of the CSS matters, but it is not the only arbiter of what rules get applied with which priority. So as you may have noticed already in your CSS time, it's entirely possible to have, say, 2 background colors applied to the same div from 2 different rules, and CSS has to decide which one gets applied, right? Generally speaking, order is one of the first criteria there. So any CSS rule that comes later will override any rule that came before it that applies to the same element. However, there are things like specificity. So the more specific a selector is, the higher priority it gets. So even if a selector comes later in the file in your CSS, but has a lower specificity, the earlier rule will still take precedence. So all this to say, in CSS and HTML, order is important, but also a little squishy. The order of the lines of code you write and the order in which they get interpreted and applied are not necessarily a clean one-to-one relationship. When we get into a traditional programming language like JavaScript, that order is a lot more explicit. So essentially, when we move into a JavaScript file, and I'm going to show you this here in a minute with a debugger, we can watch it run line by line. And so we can actually think about our JavaScript as getting sort of played back in real time. And when that JavaScript gets played back, if you literally envision that you have, you know, a playback head, like a highlighted line there, and that is going to move through the file one line at a time and do whatever that line says. Now that line may make it jump somewhere else, and we'll look at an example of that. But then that playback head jumps to the new location and then keeps going one line at a time till something makes it jump somewhere else. So when we're dealing with JavaScript, which is a single-threaded language, generally speaking, we're not going to get into the details of what that means, but just think about, you've got this playback head that is tracking through your code and executing those instructions one line at a time in order, which is not really how it happens with HTML and CSS, where those whole files get loaded and parsed by the browser and rendered out into some visuals, okay? So let's talk a little bit about responsibilities in that ordering, and we'll come back to seeing how order really works in JS. So I'm going to give you a quick demo with a debugger so you can actually watch some code run line by line. So responsibilities. So now we know some HTML, which is hypertext markup language, right? That's what the acronym is. So it is a markup language. Does anybody want to Slack or Zoom chat and tell me what a markup language actually is? Or just open and unmute and speak up? What makes it a markup language? If the word markup is intimidating, anybody want to just explain to me what the purpose of HTML is? Like, what does it do? What are we writing when we write out an HTML file? What are we explaining or telling the computer to do? You all are so quiet.
Create a structure for a document.
That's exactly it. So all a markup language is a language that allows you to write a document that has extra to it, has markup to it. So things getting wrapped in tags, things having styles applied. These are, you know, things being bold or italic or emphasized or having, you know, these other tags, right? When we actually render out the HTML, we don't see the tags unless we screwed up. It's entirely possible to see the tags if you've made a mistake, unless you're trying to show tags. But generally speaking, those tags are sort of metadata for the browser to make sense of your document beyond just the text that's in it. So that's where we get a markup language. CSS is styling language, right? So what it's giving us is the ability to apply styling to our markup. in ways beyond just writing style tags in the markup itself, which we can, of course, do. But both of those things are basically describing the structure and appearance of a document. Notice we haven't made it do anything. So now we're getting the keys to the castle that let us do stuff. So with the exception of maybe like CSS animations, which can kind of create some interactivity on the page, I suppose, without JavaScript, your document is just a document. So you can render it out and you can make it pretty and you can make it animate itself into being pretty, but you can't make it, quote, do anything. With some really minimal exceptions that are built into HTML, like submitting a form or navigating to a new page with a link, right? You've done those actions, so to speak. But you can't make the page itself do anything. You can't. It's hard to dynamically change the text somewhere, change the color of a button on the fly, etc. Right? So this is where JavaScript comes in. And so our primary responsibility of JavaScript in the browser context anyway is handling dynamic content and events, right? So anybody somebody speak up and give me some examples of what might be some dynamic events or dynamic content we'd see in a browser situation?
Drop-down menus.
Yeah, drop-down menu. So that would be some dynamic content, right? The menu is there and then it isn't. So our content changes. And what's in that menu could also change depending on who the user is that's logged in, let's say, for example, something like that, right? So that's a good example. How about some events? Anybody have a thought about an event, what an event might be?
Not sure this is event, but it makes it interactive. So dynamic based on you make one change, it then displays differently or renders based on that change of the logic and that change you made. Like a radio button, for instance, you hit one option, it presents additional buttons or additional options.
You just covered both for me. So the dynamic content part would be whatever showed up after you clicked that radio button. So what's the event?
Clicking the button.
The click, that's it. So click is an event in JavaScript. User clicked on something, that's an event. User scrolled on the page, that might be an event. The page finished loading, that's an event. So there are both events that are user triggered by the user interacting with something, and then there are also some native events built into the browser, like you get an event when your page is done loading, and those sorts of things. And so JavaScript gives us the ability both to emit those events, in other words, to like create an event, or to listen for an event and then respond to it. To use Neil's example of you click a radio button, so that's our event. Our listener for that click event on that radio button will have some code associated with it that will get run whenever the listener hears that click event on that element, okay? So that's the basic idea of events. And we're going to take a whole nother pass at events in another class. I'm going to talk a little bit about this idea in JavaScript of the event loop, which is a fairly heady thing to wrap your head around. And we're going to just cover the very high level version of it. But essentially, you can think of JavaScript running in this sort of perpetual loop. And what it's doing all the time is every time it comes around on a loop, it's saying, okay, what events have happened that I need to handle? What code do I need to run? And that process just kind of continues on and on and on and on. So we're basically going to be using JavaScript in the context of our browser environment to either change the content of an element, to hide an element, to show an element, to destroy an element, to create an element, to go get some data from the local weather service or whatever it is so that we can display that. That would be dynamic content, right? The weather changes every day. So we need to go ask the weather station what the weather is, or if you live in Oklahoma, the weather changes a lot more often than that. So we'll have to fetch more regularly, right? So that's basically why we need JavaScript for these things you've been writing in the browser. You have reached the limit of I can make a really pretty document and style it, but I can't make it do anything when I click on stuff except navigate to another page or submit a form. And so JavaScript's going to give us the keys to do all of that stuff. I mentioned briefly, I'm going to drop all the way down to my last point just because I mentioned it already as a touch point. I keep talking about doing all this stuff in the browser. So one of the things I want to explain real quickly, and don't get too hung up on this, but JavaScript is what's known as an interpreted language. So most programming languages out there fall into either an interpreted language category or a compiled language category. And for your intents and purposes at this point, all you really need to understand about that is whether or not there is quote unquote like a build step before your code can run. And do you need something else to run your code, or does your code get built into something that can run by itself? So some compiled languages, examples would be C, C++, Rust, Go. These languages, when you're done writing code, you can compile down a program that can run on its own. That's basically the idea there. JavaScript is not one of those. Python is not one of those. You've heard of Python. They are interpreted languages. So they need some type of runtime that literally just reads your code and runs it on the fly. So the beauty of that is I can hand the JavaScript I wrote to this engine and let it do its thing with it. It knows how to read JavaScript and make sense of it without it getting compiled first down to machine code. So in this case, we've been talking about everything in the browser context, and you can run JavaScript in the browser because the browser has a JavaScript runtime built into it. In Chrome, that's known as the V8 engine. So if you ever come across the term, somebody talking about the V8 engine in Chrome, that's just Google's JavaScript runtime that they bake into Chrome. Firefox, I can't remember the name of theirs. It's something like Star Kitten or something fun and fancy like that, because yay, Mozilla. I'm a Firefox fanboy. I'm unashamed about it. So each browser environment is going to either use V8 or something or use their own proprietary JavaScript runtime, but they have their own program running to run your JavaScript, okay? And down here on the bottom here, I've mentioned a few others that exist outside of the browser. So Node is probably by far the most common one. So if you've ever heard of Node.js, all Node really is another runtime that doesn't need a browser. So it allows us to run JavaScript not in the browser. Deno and Bun are two others that are coming up. Also just other ways to run JavaScript outside of the browser. So we're not going to dig into that too much. We're going to stick in the browser for now because that's an environment you all are the most comfortable with. I just want to make you aware that the browser is running your JavaScript. And that means it has some rules about it we're going to get to here. And you can also run your JavaScript not in the browser, but that will change the rules just a little bit. So let's get into that a little bit and look at how we do this. So
Quick question. You said Node is not in the browser, and then is that right? Okay.
Yep. The browsers use most people don't know what engine their browser is running unless they actually work on that, because it kind of doesn't matter to you. Browsers follow, and there's this link down here in our curriculum that I'll pull up here in a second. And we'll just go there now. That's fine. You want me to go there? Magic. Oh, you're going to do it in another window. Hold please. Coming over. You'll see that. So this is linked in the curriculum for you all to look at. This is the web API. So these are basically all of the things that you can do with JavaScript in a browser. And so whether it's Firefox or it's Chrome, theoretically, any of these standard APIs should be implemented in both of those browsers. So you can run the same JavaScript, and it doesn't matter to you that it's Chrome's V8 engine or Firefox's whatever, until you use some esoteric feature that it turns out Firefox didn't implement the same way Chrome did. But that's pretty rare. So this is the web API. And for comparison, if I just pulled up another tab, and again, I'm not going to rabbit hole into this, so don't let me do that because it's easy for me to do. But if you just go to Node.js, you'll see here, I don't want to download it. I just want to go to the docs. Thank you. So here is the whole list of all the stuff you can do with JavaScript and Node, a lot of which is the same. There is a lot of overlap. But one of the common differences, for instance, is like file system access. So your computer by default is set up in such a way that your browser is not really allowed access. JavaScript running in your browser is not allowed access to your local file system. I know some of you during module 1 had some issues trying to like load in images from your local file system directly in the browser. And that is a security feature. It is considered a feature, not a bug. The browser is limited as to what it's allowed to access on your local machine, because we all know the internet can be a cesspool of people trying to shove bad code into your browser. So if you want to, for instance, write some JavaScript that does something like download all your bank statements into an Excel spreadsheet and do some math on them for you, you're going to end up wanting to likely do that in Node, because you're going to be interacting with the local file system and all that sort of stuff, and you don't really need the browser for anything. So if you're writing a full stack web app, your whole back in JavaScript, your whole backend would likely be written in Node under most cases, but you could use those other runtimes. So
And I don't want to deep dive or get off topic, but you would basically stand up a server, install Node.js kind of as the framework on it, and then the server would know how to process. Is that?
yeah, essentially Node.js would be the runtime that would run the JavaScript. And then if you were actually running a web server, you would likely add a web framework, Express being probably the most commonly known one for that. And that would be able to handle, your HTTP requests and all that sort of stuff. But to just
Thanks.
actually execute any JavaScript at all, to write a web server in JavaScript and run it, you need a runtime that isn't in the browser. And that's where Node would come in. So you can literally just, it's npm install Node and run some JavaScript. We'll do a little tiny bit of that today.
Perfect. Thank you.
You bet. So cool. Well, let's look at it from an HTML perspective first. So we've got our HTML here. We have a few ways we can integrate JavaScript into our HTML. The simplest of which is to just write it right in the HTML file. So if I give myself a set of script tags here in my body, I can now, anything between these tags, the browser is now going to read this like it's JavaScript, not HTML. So I can do something as simple as alert. Hi there. Now, alert is one of those functions that's baked into the web API. So browsers are supposed to expose a function. I'm calling a function here. That should be hopefully familiar to some of you from role-playing game time. I'm calling a function called alert, but notice I didn't have to write that function or define it. That's built into the browser. So I'm calling the function alert, and alert takes one argument. It's a string, and that string is the message you want it to show you in the alert box. So in theory, I haven't tried this today, so let me see if I can get this thing to pop up in a happy little window here for me. And it did, except for the part where when I moved it, I lost my pop-up. Okay, so you can see when it loads, I get my little alert pop-up. Hi there, magic. I just ran JavaScript in the browser from an HTML page. That's literally the most simplistic version of JS there is. Okay. So hopefully some of you are playing along at home and got that to work for you. Alternately, and I can write, I can write more in here, so I'm going to write another one. Let me do a console log instead here, because we're going to talk about the console next. Okay, and now I'll pull my little tab back over here. I'm managing too many screens. Okay, so I've got my hi there. I'm going to open up the browser dev tools here. And I'm going to refresh this. I'm going to hit OK. And then after we ran my alert, notice that I didn't see this hi there console pop up in my console until after I cleared the alert and hit OK. Because that alert function is holding that playback head till you hit OK, and then it will release it to move on to the next line of code. Because alert is waiting for a response. So here's my little hi there console. So this is the browser console. We can do a lot of things in the browser console. So you just saw one of them, which is I can log to it. So let's talk a little bit about the structure of this code, because I want us to be able to read. So when we call console.log, what we're calling here is we're calling a function. The function is called log, and it is defined on an object called console. So, and this console inherently is a globally exposed variable by the browser. That may mean nothing to you right now, it will in a minute, but the browser gives you the console object, and you can do things with the console. Primarily, you call the log function or the error function on the console, which just gives you different levels of output. So I could, for instance, change this to a console.error. And I'm going to go ahead and get rid of my little alert so we're not having to watch that over and over again. And now you notice that when my page loads, I still have hi there console, but it's giving me the big error warning. Your page threw an error. So I can tell my code, JavaScript, to tell the browser that there was an error instead of just a log statement. And that's why this is, highlighted in red here for me. Error warning. But I want to point out something else important here in our console. Right here on the right, we get the source code entry that triggered this console output. So it is in my inclass.html file on line 13, column 17. So if I go back to inclass.html and I go to line 13 and column 17, oh, look, here's where we called console.error. So when you're seeing errors or you're debugging and we're working on those processes and you're putting stuff in the console to help you out, be aware that it not only gives you that line map reference there, but in most dev tools, if you have what are called source maps set up, which I think VS Code kind of handles by default with the live server, this is actually a link. So if I click that, it's going to actually show me in my console the exact line of code that triggered that. Okay. So let's do, while we're in here looking at console, I'm going to talk through the debugger just a tiny bit. We're going to get way more into debugging later, but I think this is going to help show you that idea of the order of the code mattering. So I'm going to write a few more lines of code there. Change this to a log so that we're not so dramatic about it. And we're going to do another one. Okay. And then what I'm going to do, there's a couple of ways we can trip the debugger, but one of the easiest, most explicit ones is actually this debugger keyword. So if I just write the keyword debugger on its own line in JavaScript, when the browser tries to run this, it's going to pause right here and open the debugger. And the debugger is a tool that just lets us kind of watch our code run step by step. Very useful when we have a bug and we're trying to figure out where things went wrong. But also helpful in this use case to just kind of see what's happening. So when I refresh this page, which I did already, you can see now I've got this thing here in my browser that says we are paused on a debugger statement. And over here in my console, in the debugger tab, so look a little different if you're in Chrome, but they both have these tools. I'm in Firefox right now. You will see that right now we are frozen on line 13 where I put in that debugger statement. Okay. Line numbers become really important when you start dealing with code like this because we are talking about order and matter. Otherwise, when you start writing longer files of code, trying to remember where that function is that you're dealing with gets tricky. All right. So my debugger gives me a few tools here, some of which are off my screen because my thing is too small. So I'm going to make this a little bigger here. And this is the other half of my debugger. So right here, we're paused. And we'll get into what all of this stuff means in another class, but this is going to show me kind of the current values of variables, which functions have been called, all that kind of stuff. But really what I just want to show you right now is watching us. I have this step over, which is going to step through my code without diving into the internals of the console.log function. So when I step over once, I now move on to this line and I'm frozen here. Notice no output in the console yet, because we are paused on this line, but we haven't executed it yet. When I step over again, hi there, console, and now we're frozen on the next line down. And if I step over again, now we get hello again, and now we're paused on our third one, and then I can let the code finish running, and it will finish hello the third time, page is done, okay? So this is the idea of JavaScript running in order, and a real wild intro to the debugger. I said there was a couple of ways you can introduce the debugger. So when you tell the debugger where to stop, what that is called is a breakpoint, which is what this whole list is over here. And you can see right now it's just set to pause on a debugger statement, which is what it did for us. But you can also do this without writing that in your code. So I'm just going to take this guy out real quick and go back to our console. Now you'll see when I refresh it the first time here, it just ran and I got all three of my console messages output because nothing was pausing anywhere. But if I click just to the left over here on the line I want it to stop on, now you see I have a new breakpoint right here in this file, in my little breakpoints list here. And now if I refresh the page again, it's going to pause on that step just like it did before when I wrote debugger on the line above. And now I can come back in here and step through my code one line at a time if I want. So there's lots of good crash courses on the internet on debuggers and all that sort of stuff. And again, we'll get into it more in depth, but I am going to try to get you comfortable with the debugger early on because it's a really helpful tool in seeing how your JavaScript is actually running while you're running it, until you kind of have this idea of control flow intuitively in your bones there. Cool. Let me go back to our VS Code here. All right, so we kind of just covered my next 3 points all at once, because I want to do that sometimes, but they're all related. So we've looked at the console a little bit. we've looked at it in terms of our ability to log to it, our ability to output errors to it. And then we've also looked briefly at the debugger. But there's another thing you can do with the console that I think is often underrated when you're learning JavaScript. This console down here is essentially what is known as a REPL, R-E-P-L. Doesn't know what that is, but that's an acronym. Anybody know what it stands for? No, cool. It is a read, execute, print loop. Most programming languages offer some version of this. And even when we switch runtimes over to something like Node, Node also gives you a REPL. REPLs are really useful learning tools because what it does, let's break down that acronym. Read, execute, print loop. So it is just waiting for me to give it something to read, as in I've typed in some JavaScript. As soon as I do that, it will read that JavaScript and then execute it. It will print out the results, there's the P in the REPL, and then loop back to the beginning and wait for the next thing to read. So without having to write a whole program, I can test some basic JavaScript here. So right in here, if I wanted, I can do console log foo. And when I do it, oh look, my console output foo. It did a thing. Notice it also printed undefined here. Anybody have any idea why it printed undefined here? I don't expect you to, but you will soon enough.
Because we didn't declare.
Haven't defined a variable?
So this is actually the return value of the function I just called. And console.log does not return anything. So our return value is undefined. And Firefox gives me this handy little arrow to the left in front of it to show me that's the return value. We're going to talk more about functions and function signatures next. But if I declared a variable, for instance, if I said const foo equals bar, now it printed out bar because that's the result of assignment. But now if I also just grab foo, I'm going to get bar back for my print because foo equals bar. So when I said read here, read the value of foo, execute it. Well, executing a variable just means reading its value. That's all it is. So it printed out the value and now it's looping and ready to run again. So this is a really useful tool, especially when you're learning for things like I'm trying to learn a new method on a string or a new method on an array or on this web object. And I think I understand how it works, but I'm not sure. You can call that function with a little sample input real fast and see if it does what you expect it to do before you're trying to run a whole program with that code baked into it. So REPLs are really useful for kind of testing small bits of code and making sure that it's working the way you think it is in isolation without needing to run your whole program just to find that out. So imagine you get a little REPL here for fun in your console tab too. And in Chrome, you get the same options. I will pull just a Chrome example over here. F12 is the hotkey on most systems for pulling up your dev tools. You can also right click and go to inspect on a page and you'll get them here. That takes you to the elements inspector. And what I'm interested in here is the console. So you can see it looks a lot like my JavaScript console in Firefox. And I can do the same things here. So I can do const foo equals bar, assign it to a thing. Interestingly enough, though, it does not print the result of assignment as assignment in Chrome, which I would have expected it to. But if I execute foo again, it does show me its value. Okay, so that's a REPL. Very easy way to test some code. All right, here's the quick Node sample I mentioned, just since Neil asked about it. Don't worry too much about this. I already have Node installed on my machine, so this would require setup for you. But I can, if we have this in-class.js file here. I'm just going to do something in here like console.log, because console.log also works in Node. It just prints out to your terminal instead of printing out to the browser console. But hey, from Node, I can do that. And then now I have a program. So I can just run node in class.js. And there's my printout. There's my console log. Okay. So now I just ran JavaScript without the browser. Same idea. So no expectation that you all are getting into Node or anything now, but if you're at all interested, just know that that's literally all there is to running some JavaScript in Node is type node and the name of your JavaScript file you want it to run. It will run your JavaScript. Magic.
Now, is Node and Node.js, is that synonymous?
Yes, yes it is.
Okay. Thank you.
And I mentioned Node also gives you a REPL. Really easy. If I just type Node without an argument, I now have a REPL. So I can do exactly what I was doing before. Const foo equals bar. And then I can ask for foo, and I know that it's bar. Right. So fun little REPL there. And you can do things. So I can define a function here that says, do something. We'll do say hi. Notice it gave me 3 dots because I'm writing multiple lines right now. We'll come back to that. It's going to have this console.log out. Hi. Close my curly brace to finish my function. And now I've defined a function. So I can call it. And now it console logs out hi. And also the undefined return value because this doesn't return anything. Okay, so basic idea of a REPL in Node is almost identical to using it in the browser console. So no reason to go to Node for any reason yet, but just making you aware that mostly bringing this up because I want you to feel comfortable kind of starting to poke at the debugger and the dev tools and your console to help your understanding of JavaScript. But it's also important to understand that there is a thing running your JavaScript, whether that's the browser runtime or Node or whatever. So there is an interpreter, and that interpreter has an API available to it. So there are functions you can call in Node you can't call in the browser, and functions you can call in the browser you can't call in Node, and things like that. So just a little bit of ecosystem awareness there. All right. Close my terminal here for a second. Okay, so that's the console. And then we talked a little bit about this idea of do something or store something per line. You did see me just write a multi-line function in Node real quick in the REPL. But think about the idea that generally speaking, every line of code you write is either storing a value or executing something. That's what every line is doing, either execute a thing or store a thing. There's obviously more nuance to that, but if you start from that premise and think about it line by line, that's going to help you kind of keep your head straight. It's really easy when you start writing code that does stuff and runs on its own to write so much code before you tested the little things out that now it's not working, but you're not sure where because your code does a lot of stuff. And so thinking about it line by line and having the ability to put stuff in a REPL or log things out to your console, useful. So we kind of talked about program execution already. That's essentially just this idea that you have this runtime that's going to read your code line by line and do what it says. And we also covered the debugger. So, and we also covered kind of browser and Node API. So I'll leave a little room for questions on any of that stuff. But what I want to get into primarily is variables, types, and operators here with the remaining time we have left, because this is kind of one of the first big chunks you bite off in that role-playing game exercise, and also kind of just a core fundamental, not JS specific set of concepts we need to understand when we're writing code that runs programs, okay? So let's talk a little bit about variables first, okay? So you've seen me declare a bunch of them already. So primarily in JavaScript, we're going to declare a variable either with let or const. So here I've declared 2 variables. It's a little mad about the way I did bar there, but that's just my editor warning me about something I'll explain in a second. Those are both totally valid-ish declarations. The const one, not so much, and I'll explain why. There is a third one. You can do this too, but we don't really do that very often anymore. There are very specific reasons to occasionally, but don't worry about that. So for these purposes, for this module, use let or const all the time when you're declaring a variable, and you keep yourself straight. Anybody explain the difference between let and const for me here?
Const doesn't change, and let you can change the value.
Yep, that's exactly it. So when we declare a const, if we try to change the value of that variable later, JavaScript will yell at us and be like, you tried to change a const and you're not supposed to do that. Let.
Where will it yell at you? That was something I wasn't clear about. Like,
Yeah,
can I
let's look.
have a let foo and a const foo, and where will it yell at me?
Yeah, so you wouldn't be able to have both, because if I try to do const foo here, it's going to yell at me for trying to declare a variable with a name that I already have. But let's do this one. So let's see why it's mad about this one right now. Notice its error message I'm getting in VS Code for me here. Const declarations must be initialized. So as Tandalea pointed out, like we can't change this once we initialize it, right? So if I never set it to a value when I initialize it and I can't change it, I've just declared a variable that is permanently undefined. JavaScript thinks that's a mistake, and it probably is. So here, let's just set it to 0. That's fine. Now it's happy. I have 2 of these things. If in here, though, I try to now say in my code bar equals 1, when I go to do anything with this, any tools that are running my JavaScript, let's see what happens here if I run this in Node, so I can answer your question about where you're going to see it. Let's log out the value of bar at this point. I'm just going to run it in Node to not have to go to the browser for now, for the sake of speed. Okay, so I am in the wrong folder. That's a totally different error it's yelling at me for because I closed my terminal. Sorry. All right, type error, assignment to a constant variable. So I'm getting a big old node blew up on me in this case. So if I had done this in the browser's V8 engine or a Firefox engine that's running the JavaScript should blow up and yell at me because I tried to assign something to a const. So you would see it in your browser console. Let's try it. So here in our script, let's do the same thing. I'm literally just going to grab exactly what I did over here. And I'm going to go over here and paste all that in, indent it over. So let's see what we're doing. Okay, so same idea here. And now if I go back to my browser tab, if I can find it, here we are. Let me take my breakpoint out so we don't see that happening. And then let's refresh this guy. And look at that, big old ugly type error in my browser console. Invalid assignment to const bar, same exact error, okay?
Would I see anything on the screen or only in the console?
Only in the console.
Okay.
So all the screen in the browser is trying to do is render out this HTML page, and it failed in trying to do so.
Okay.
So the only way that we would see anything here is if we had written our HTML in such a way that there was some fallback state where if JavaScript errored out, it showed us something, but we would have to build.
On the screen, I get a white screen, and then I go to the console and I see that there's an error there.
Yep, exactly.
Awesome.
So your JavaScript, because it's running under the hood, whereas your HTML and CSS get rendered by the browser when the page loads, like that renders out your document, and then it will execute your JavaScript. So because your page is already rendered when the JavaScript starts running, any place where the JavaScript blows up on you is going to end up appearing in your console.
So if we're talking order of operations, it's HTML, then CSS, then JavaScript.
Yep, generally speaking, that is accurate.
Okay, thanks.
You betcha. All right, and you can even see here in my debugger, Firefox has given me a clue that this is exactly where the problem happened. And again, over here, I also see it. It's in inclass.html on line 16. Right here. Oh, look, yeah, I assigned bar. Now, if I just change that from a const to a let, which I can't do directly here because that's not what I'm trying to do right now. We can change this to a let, and now everything should be happy in both places. I can run it again in Node. Just kidding. What did I do there? I didn't save it. Why is Node wigging out? I think my keyboard shortcuts are getting hijacked by Zoom because, oh, sorry, I'm in the in-class HTML. Nope, I'm just being dumb. That was on me. Cool. So in here for Node, if we change this to a let, and I go rerun it here. Hey, now I just get one, magic. It let me change bar, no errors, no problems. And we'd see the exact same behavior in the browser in the console. If I come back over here to our browser tab where I had already changed it, and see now I don't have any errors here. We do have this 404 error because it's looking for a favicon file for the site that we don't have, but we're not seeing any JavaScript errors here now, and nothing highlighted up here. Okay. So with that in mind, let's talk a little bit about types. Okay. So variables all have types. Types are a little bit abstracted away from you in JavaScript because it's what's called a duck-typed language, or if we're going to be more fancy about our technical terms, it is a dynamically and loosely or weakly typed language. So languages fall into 2 categories in terms of their typing. They are either strongly or weakly typed. Okay, and strongly or weakly typed means, are you allowed to change the type after you've initialized the thing? Oh, fun, I got thumbs up from Google's. And dynamically versus statically typed means will the code say, if I hand this thing a string that should be a number, but it's a string you could use like a number, will the code just try to use it like a number? Or will it throw an error because it's expecting a number and I gave it a string? We'll talk about numbers and strings in a second here. JavaScript is about as loosely and dynamically typed as it gets. It is often referred to as a duck typed language. Anybody know what duck typing means in this case? You know the idiom, if it walks like a duck and quacks like a duck, it's a duck. That is duck typing. So JavaScript will say, if I can make any sense of that variable at all, even if I have to change its type to do so, I will do my best to just try and keep going. You will run into all kinds of people with all kinds of opinions about whether that's a good or a bad thing. I think it's just a thing you need to understand, okay? So even though we don't, because JavaScript is so loosely typed, we don't see much of the typing in the actual code. So if we go look at our types here, I can hover over foo, and now TypeScript, which is an add-on to JavaScript built into VS Code, is giving me a little bit of clues here about the JavaScript underlying type. This one here is referring, foo is any, which is not really a JavaScript type, it's a TypeScript type. Foo is technically undeclared at this point. It's in what's called the zombie state of JavaScript variables. Undefined is an actual value you can assign in JavaScript. This isn't undefined. It actually just, it exists, but has no value at this stage. So we do something with foo. So TypeScript says, oh, that's any. It could be literally any type. We don't know what it is. Whereas bar here, it knows is a number because bar has a value. Okay. And if I initialize foo to 0, but in quotes, just to confuse everybody, notice it knows it's a string, not a number, okay? So I got 2 zeros here, but they're slightly different zeros, okay? So why do we need types? Well, everything that goes into your computer is nothing but a string of ones and zeros. So when we store a value in a variable, when we define a function, when you write your HTML, all that stuff, it is all ones and zeros. That's all it is. And so this quotes with a 0 in it and this number 0 here are both stored as ones and zeros. But obviously they're different. And so JavaScript needs to be able to know how they're different. And so when we tell JavaScript what type something is, or when our engine tells the computer what type something is in JavaScript, it's saying, when you read those ones and zeros, here's how you should interpret them. Treat them like a text character. Treat them like a number. Treat them like an object, treat them like an array, et cetera, et cetera. Okay, so that's where types are coming in. It's just how we're telling the computer how it should interpret the underlying ones and zeros for this value, this function, et cetera. Okay. For the purposes of making that a little extra clear in our last few minutes here, I'm going to change this file to a TypeScript file. I'm not expecting you all to learn TypeScript, but it's going to let me kind of show you how we could be more explicit about this. So if I was writing this in TypeScript, all valid JavaScript is valid TypeScript. TypeScript is a superset of JavaScript. So it just gives us some window dressing to get explicit about types in JavaScript, which can be really useful. So here I could say foo is a string. And here I could say bar is a number. Okay, and now in this declaration, what I'm saying is, okay, I want a variable I'm declaring with let, so we know we want to be able to change it. Its name is going to be foo. Its type is going to be string. And I'm going to give it an initial value. Now watch what TypeScript is going to do to me if I change this to the regular 0. Now it knows foo is wrong because I can't assign a number to a string. This is where TypeScript starts to become helpful. JavaScript wouldn't really care. It would just try to treat it like a number when I tried to do math with it and try to treat it like a string when I didn't. But let's look at a really fun example of this. I'm logging out bar here already. So let's do let foo equal 1. Let we're going to log out baz instead here. Bar equal 2. Let baz equal foo plus bar. What's going to log out when I run this?
Foo bar.
The sum? Oh, okay, I see.
We've got 2 theories here, foo bar and the sum. Anybody else want to take a guess before I run it?
I'm going foo bar.
It's gonna say
It'll show 12.
So why did I get 12?
Oh,
Because
Because you
in
do clear-
JavaScript, go ahead, sorry.
Oh, because number 1 and number 2 are in quotes, which treats them as a string. So it's not going to do the math on them. It's just going to print them.
Oh.
Right, because the plus
Concatenator.
operator, so now we've just introduced the idea of an operator. Okay, so here I have a variable and an operator. So operator just does something to a variable, okay, or to a combination of variables. So in this case, the plus operator, if we have strings on both sides of it, is the concatenation operator. Bump the strings into each other.
Ah.
But what happens if I do this? What are we gonna get? Get ready for some JavaScript weirdness, y'all.
It won't render.
I just want to
No,
see it.
I got the same answer. Why? JavaScript duck typed it. It said, well, one of those is a string, so you must be trying to do string concatenation, and so we'll just treat the other number like it's a string. That works. Why not? If I change this to a number also and change nothing else about the code, I get 3. Because if it's numbers on both sides of the plus operator, then it is the addition operator, and it will add the 2 numbers together. Plus is the only one that gets real weird for you that way, by the way, in math. JavaScript is pretty straightforward that minus and multiply and all of those operators you'd expect in division generally will do math. And if you try to use them on strings, it will just throw an error because it doesn't know what to do with them. But the plus one is the gotcha. And I've seen that 1 + 2 example so many times bite people where they have things that are coming in from their HTML as strings representing numbers, and they try to add them together, but they haven't turned them into numbers yet. So what if I have this, but I want 3 to be my result? Anybody got an idea how I might do that? If I actually wanted to treat these like numbers and add them together.
Put them in parentheses or
Then you're very close. So what we're gonna do is
curly
cast them.
brackets. Oh,
No, you were closer with the parens. So what we're going to do is explicitly cast them to a number. And so what we can do is call the number constructor. We'll talk about what a constructor is later, but it's just a function here. And I'm going to hand it a value, and it's going to make me a new object, a new number object out of that string. If it can't parse the string into a valid number, it will return a special value that looks like this, not a number. NaN is a special type in JavaScript, which is you tried to do something and make a number and I couldn't, so you get NaN back, not a number. All right.
now will it try to take a
think you
letter
cut
and turn
out.
that into a number?
You'll get NaN if I do that. I'll show you
Okay.
the example right here. So now I'm getting 3 back, even though I have strings, because I've explicitly cast them to numbers before I added them together.
Now you've lost me.
Yeah, okay, cool. Let's circle back on that. Here's that NaN to answer Neil's question before I go back, right? So I got not a number this time because it does not know. I'm saying, hey, make a number out of bar, and it doesn't know how to make foo into a number. It knew how to make 2 into a number, but not foo. So what we're doing here is changing the type explicitly, meaning we're literally writing code that says change the type of this thing. I'm saying change the type of foo into a number temporarily, and change the type of bar into a number temporarily, and then use the plus operator. And since they're both numbers, that will become addition, not concatenation.
And because you run it line by line, if initially at lines 4 and 5, it's set as a string, but then as it gets down to line 7, the cast takes over what was said above. Is that right?
Sort of. It is. I'm explicitly casting it to use it for this operation, but oops, foo is still a string after this.
So just in line 7, it takes the
creating
cast.
a new thing here. I'm just not saving it in a variable. So I'm getting saying brand new number, but make it out of foo, and give me another brand new number and make it out of bar.
But if you jump to line 10 and then call the variables again, then it's back to being a string.
So there's a type of operator that will print out the type of a variable. So to answer your question, there you go. I've got NaN and string still, because they're still strings.
Very cool.
You
Thank
need
you.
to put line 7 above line 4.
If I do that, I'm gonna get an error. Why am I gonna get an error when I do this? See where my error squigglies are?
Because those are undefined.
Yes, we haven't defined foo or bar yet, but I'm trying to use them to make a new number. So can't use a variable until you've declared it.
Wait, so let me wrap my head around this. You've done a let foo of 1, a let bar of 2, but then you've defined them as a number in 7.
So in 7, let's not think about this as defining this as a number. I am temporarily creating a brand new number out of foo.
Okay.
So I could do this. The names are arbitrary. But just for clarity, and then here. I could do- Does that make sense? This is functionally equivalent. I was just doing these 2 steps in line because I wasn't going to do anything with foo number or bar number later, so I didn't need to save them.
So when you, if like further on you wrote down, it would still be a string if you needed to use it as a string later because you're just kind of casting it as a number temporarily.
Yep. So here I could do, let's log out all these types real quick. And so at the end result now, I'm getting 3 because we're adding the number variants together. But you see I have 2 strings for foo and bar. And then I have 2 numbers for foo number and bar number, which were created from foo and bar. So if I change this to 7, foo number is also gonna change to 7. So my math is gonna be different. Now I get a 9, right? But as Neil pointed out earlier, if I go in here and I make this something we don't know how to make a number out of, like not a number, we don't know how to make that into a number. Then what I get is not a number as the result of that addition because it doesn't know how to do math. I'm saying these are both numbers, but
Okay.
actually, if I log out foo number, let's do that real quick. Foo number's value is NaN because we tried to make a number out of it and it failed because nobody knows what number foo number is. So therefore it's not a number. Okay. And with that, we are at time. I know I just dumped a bunch of stuff on you. But I want to dig into types with you and make you start thinking about the types bit. So as you're working in JavaScript, every time you declare a variable or pass one into a function or do something like that in your exercises, ask yourself what type that data currently is. In JavaScript, there's only a handful of native types, and most of them you've already experienced. Number, string, array, object. That's going to cover like 80% of your use cases for this whole module if you kind of really understand those 4. And we're going to dig into those deeper as we go. And then knowing that how operators behave depends on what the types of the data they're operating on. Okay. So that's kind of where we're going to wrap this up. Your homework for next class. Finish up the dragon slaying role-playing game if you haven't yet, and that'll give you some more context for this. And then the other thing I would like you to do, and you all, this is up to you, how much of this is or isn't useful and what you would like to get out of it here. I'm in module 1 here. I'll drop this in the Slack as well. There is one of my favorite JavaScript resources is javascript.info, the modern JavaScript tutorial. And so you can look at sections 1.1 through 2.8, and you don't need to read all of them cover to cover or anything. Look at the topics and be like, yeah, I understand that already. I don't need to read it anymore. Or this was something I'm really feeling confused about right now. They're good, useful little review snippets on variables and data types and the things we just kind of went over, including the browser, editors, all that stuff. That's my recommendation if you're a document-oriented person like myself who would rather read it. If you want the sort of step-by-step hands-on, also in the syllabus, there is a link to, in the free code camp curriculum, the old, oh God, I'm not logged in here. The old JavaScript curriculum that we used to use here is linked in here for you also. Let's see if this will pull up for me. Yeah, so this is the legacy JavaScript algorithms and data structures. There's some outdated stuff in here when you get further on, but for this first chunk, I think it's also pretty valid. Just know that they're gonna probably do a lot of declaring with var to start instead of let or const, but other than that, it's gonna be basically the same. This walks through also the same stuff I just pointed out in that JavaScript info. So variables, types, data structures. Do not do both of them unless you're feeling really froggy. But if you want to step through this down through, I think on the syllabus, I marked through the shopping list exercise. You can click through this and then same thing, skip ones you feel really comfortable with, dig into ones that you're confused about. So there's kind of a hands-on option or the read the docs option and play with stuff in the browser console or the REPL. That's all I'd like you to work on between now and next class is kind of review these topics and finish up the Dragon Slayer if you haven't, and come next class with questions. If you've already finished Dragon Slayer and you're bored by all this and you're wanting to push ahead, we're going to do after Saturday, we're going to do the next exercise in the Free Code Camp curriculum, which is the Learn Form Validation project. So it's just the next one down after the Dragon Slayer role-playing game. You can feel free to start that, but that'll be Saturday's homework after Saturday's class. And that's it. I'm happy to hang out for a few minutes if anybody has any other questions, but I certainly want to hold you past your time. So I already did by 5 minutes. So that's it for me, and I'll just hang out.
Thank you.
Thank you all.
Appreciate it. Have a good night.
You bet. Yeah. See ya.
So this might be way past or way ahead of what we're trying to do. But when I've dabbled in this before, I've come across something called the document object model, or DOM.
Yeah.
Can you kind of high level explain what that is?
Yeah, absolutely. That is going to be the core topic of Saturday's class. So for anybody who's still listening in, don't worry if you're heading out, you're not missing anything. We're going to go over this all again. But the basic idea of the document object model at a high level is that it is taking your HTML and CSS and rendering it into a JavaScript object so that we can manipulate it and or do things with it. So in the most sort of like naive example of that, let me just open a new file real quick here for a second, and I'll just kind of show you. So you could imagine something like const, and let me make this a JS file, hang on. So you do const document, and then you're going to have a head element, which will have maybe some other elements, but inside of it that will be in a children, which will be an array of other elements. Then you're going to have a body element, which will also have children, et cetera, et cetera. And then in this children, I might, for instance, have an H1 element that then has some text content. And it may also have some inner HTML. And you kind of played with manipulating these properties a little bit in the, sorry, I just wrote invalid JavaScript. Run an array of objects, so it's going to be tag H1.
We did a little bit of this in the dragon slaying thing, right? Yep.
Yeah, exactly. You made locations, right? And your locations had properties like their name and all of that. So you just start to think about this. If we go back and look at our HTML real quick, like I have a script tag, I have a body tag. So like all that means in the DOM in a like really high level view is that in my children here, I actually have another element, and that element has tag script. And then that script has content or inner text or whatever, I think it's going to be text content in this case is the actual node, but that would be whatever I wrote in that script, right? So it's going to be all of this as a string. Right, so it's going to be a string that says something like, and this is exactly what we're going to do in the next class. It'll be a string like, let foo equal 1 semicolon, let bar equal 2 semicolon, console.log foo semicolon, right? And now you can see how basically I'm starting to turn the HTML into a, this is also going to have like a class list for your CSS classes, which will be an array of strings. And so each sort of node, which is what they're actually going to be called, that gets created by the browser from your HTML and CSS, gets rendered out into JavaScript as a JavaScript object, and that's what the DOM is. It is a model of the document as an object. And so in your Dragon Slayer exercise, when you did document query selector or document get element by ID, it was running through this object looking for the thing that matched, and then handing you back a JavaScript object with all those properties. That makes sort of sense. We're gonna the whole next class is gonna be DOM. So
Okay. Yeah, that does help.
Awesome.
Okay.
Yeah, one
appreciate
final thing, and we don't have to talk on it now, but just something to note. I don't feel we've seen it yet. I think we were going to talk about like some of the add-ons in VS Code, like Copilot and things like that, to give us kind of boilerplate. I can't remember if we.
Yeah. Emmet snippets and stuff. I'll make a note and we can touch on a couple of those at the top of next class for sure.
Yeah, and know how to turn it on and off, because obviously you want to turn it off for the learning, but then if you're like trying to add and throw some boilerplate and tweak it and play with it, just speeds things up. So you have just some of those VS Code add-ons and things like that to know how to make it more robust and help with things like that.
Yeah, you got it.
Cool.
Yeah, I had mentioned I was going to share the extensions I have installed, and I forgot to do that. So,
I can throw up, would it be helpful to just throw up an extensions.json file? Because VS Code will read that and then you can just hit install recommended, or is it?
I do think that'd be a good idea.
Okay.
As long as we're not adding anything that's gonna be too crazy. Because it sounds like we both use Vim. We wouldn't want them to install that.
Absolutely not. No, I won't give them my extension setting.
Oh, okay.
It's tricked out for Vue and all kinds of other stuff.
Gotcha. Okay.
I would think at a baseline like ESLint would be really handy, right? And you get the TypeScript language server by default now without an extension, so they get some like TypeScript help without having to do TypeScript, which is cool.
Yeah. I would think something that formats their code for them is probably good. I don't know if we want them to learn formatting it by hand or just have something do it for you.
I mean, I have a strong opinion about that, which is that the project should set the standards and then the formatting should be automated to conform to the standards, and you shouldn't have to manually nitpick all your indents all the time and stuff like that. So that's I'm all for a tool.
Okay.
But you can configure ESLint to do formatting for you as well. And then you kind of can granularly set the rules it does and doesn't enforce as a formatter. Or we can just throw Prettier at it, which is, like opinionated no config and everything gets formatted the Prettier way, which I have mixed feelings about.
Yeah, that would be my vote for the class though. It's just something that
Prettier.
Yeah.
Cool. So I think probably Prettier and ESLint, just with like the basic default configs, is probably a really good starting point. And then the boilerplate thing, a lot of that you can do with Emmet. Like when you watch me throw together this HTML file with an exclamation point, that's an Emmet snippet, which is also built into VS Code. So that's actually a default one. So this in an HTML file and tab will give you your doc type declaration for free. But I can show we can throw up the list for that. I'll put a list in the Slack channel of those couple of extensions and maybe a link to like an Emmet snippets, how you can make your own, and or the like default ones that are readily available for HTML and JS and stuff.
Cool. Appreciate it.
Yeah, you got it. I'll do that right after this.
Thanks, guys.
Awesome.
All right.
Thanks, y'all.
Thank you.
See you Saturday.
See you Saturday.
See ya.
Good job, Eric. You crushed it.
Oh, thanks.
Yay.
Hey. Got real dark in my room. I realized by the end of that, I'm like sitting in the dark here teaching class. I'll turn lights on next time.
Yeah. All right. Later. See you all Saturday.
See ya.